everyone. So the time flies and our break ended. And let's continue today's course. And again, let me quickly recap what we learned before the break. So before the break, we talked about the meaning of expression and operator. We introduced the arithmetic operator, and we introduced some important thing we need to know when we use arithmetic operator with different operands. We need to pay attention to the mixing operand we have. So mixing operands, what I mean is that in the same expression, we have the value that have the different types. And we need to know what this kind of mixtures will, how this mixture influence the outcome of expression. And we also talk about what happens when we have the value that have minus sign. That means that if some operands are negative value, how these things influence the result. And the influence will be different depends on which operator you use. And for the division, the influence is like this. For remainder, the influence is like this. So I hope you guys can kind of remember some of this, or at least you should remember the effect is different for remainder and division. And also we talk about the precedence rules and associativity of different operator, and we talk about how we can use these two things to interpret a relatively complex expression. And then before the break, we use this slide to test if you guys understand how to interpret expression using what we learned, and we explain why the results, the correct answer is 7 here. So I hope during the break, if you still have some energy, you already figure out why the result is 7 for this quiz. So after the break, the first one I'm going to talk about is assignment operator. So now what I want to introduce is a new kind of operator. So we actually saw this operator many times because we need to assign, if we want to store a value to a variable, we need to use the assignment operator to do that. Because a simple assignment is that we can use the assignment operator for storing a value into a variable, just like I showed you here. I have a variable I can use the equal symbol to store the value 0 to the variable I. And we actually have another kind of assignment that is compound assignment. So the compound assignment is that it looks like this. We just combine the addition symbol and the assignment symbol all together. That is a compound assignment. And I will introduce more compound assignment in the later slide. Here, just one example. So if we use compound assignment, we can use it to update a value already stored in a variable. So don't worry if you don't understand the meaning here. I will provide more example to explain compound assignment in a later slide. But now, what you need to remember is that there are two kinds of assignment. One is simple assignment, just one equal symbol. The other is compound assignment. A compound assignment will be any other operator combined with the equal symbol. Then here is compound assignment, and they do different things. So let's check out the simple assignment first. So the general form of the simple assignment look like this. So the effect of this assignment expression is to run the expression E. So it is to calculate or evaluate the expression we have in the place of E, and then copy or assign or stored the return value of E to V. So what we can put at the location of E. So in this case, you can see that E can be a constant like 5. E can also be a variable like I. And E can also be a more complicated expression, just like the expression we have here. So in this case, so let's assume that I and j and k are all integer variables. So in this case, if we run this expression, then the value of I is now 5 because we store 5 to I, because we assign 5 to I. Then for the second line, what we do is that we want to assign the value stored inside I to the variable j. So after we evaluate the second line, the value j have right now is 5. Then we have our final line. So in the final line, the thing we put at the place of E is one expression, right? So we can do a calculation really quick. So now the value of I is 5. So 10 multiplied 5 is 50, right? And the value of j is also 5. So 50 plus 5 is 55. And then we assign the result of this expression back to k. So the result of this expression here is 55. Okay, it's very hard to write using my touchpad. And then we assign the results to k, sorry. So that is why the value of k right now is 55. And also when we do the simple assignment, we also need to consider the situation that is V and E don't have the same types. So for example, I have again an integer variable I, but now I have another variable called f, but the type of f variable is float. So the type of I and f are not the same. And in this case, you can see I assign a floating point number to an integer value I, and I assign an integer value to a float variable f. So when that happens, what C will do is that it will convert the value of E to the type of V. So that is why when we run the first line, you will see that C will convert this floating point value into integer value. So that is why after we finish this line, the value stored inside the integer variable j will be 72, because for the integer value, the fractional part, the part after decimal point will be dropped. And for the second line here, because what we assign to the float variable is an integer value, right? So we need to convert the integer value into floating point value. So what we need to do is just to add the point 0 at the end of 136. So that is how we can do the type conversion when we have these situations. So basically, you just convert the value to the type of the variable. And the next thing I want to introduce is the concept that is called L value. So this is L value. So what is the meaning of L value in C? So an L value represents an object that can be stored in the computer memory. So we know that the variable is an object. Variable is actually a space we have in our computer memory, right? So we can assign the value to the space through assigning the value to a variable. So that is why variable is a L value. However, what is not L value? What kind of thing is not L value? So constant we write directly on our code is not L value because our computer will not have a separate space to store the constant value itself. So the constant in itself, like 10 is not L value, but in this case, it is a variable. So variable is a L value. And for example, if you still remember, we talked about how we can use this define directive to define macro, right? So macro is that we can give a constant a name using macro definition. However, since the name of the constant is still a constant, so macro is also not a L value. So this is not a L value, and constant is not L value. And expression, although we have the variable inside expression, but in this case, we didn't assign this expression, the result of this expression to any variable. So expression itself look like this is not L value because the return value of the expression is a constant value. So we will not have the space on our computer memory to store the result of an expression unless we declare a variable and use that variable to store the result. Okay, so why we need to learn the concept of L value? So the reason is that this L value will show up in your compilation and warning message. And I will show that in a later slide. But now let's think about what kind of error will happen when we use assignment operator. So for the assignment operator, it has one special requirement. That is that for its left operand, so just like what we put at the place of V, the left operand need to be an L value. So it needs to be a space on our computer memory in which we can assign the information to. So the thing we put at the place of V need to be L value. So that is why it is illegal, it is incorrect to put any expression on the left side of assignment expression. So all these three expressions are wrong because in these three expressions, the left operands are not L value, okay? Because we have 12 here, constant is not L value. We have an expression here, expression itself is also not an L value. And what is tricky is the third line. I itself is L value, but here we apply a unary operator. So it make this place, this expression, it changed from a variable into an expression. An expression is not L value, so this line is also incorrect. And if you write any of these lines in your computer, you will get the error message like this. And actually, the error message directly tell you what happened in your code. Because in the error message, it says that L value required as left operand of assignment. And then it also tells you which line, which line is wrong. It is line 14, because when I test this code, I put this at line 14 here. And you also, and then now you can immediately know that, okay, the error is that the left operand is not L value. So I guess that is why I want to introduce L value, because if you know the concept of L value, then you have more chance to understand the error and the warning message produced by your C compiler. And again, please don't ignore the error message from your computer, because most of the time they tell you a lot of valuable information. And the next thing I want to talk about is a compound assignment. So compound assignment is look like this. So what the compound assignment can do is that it will use the old value of a variable to compute its new value. So let's just check out the example here directly. For example, I want to calculate an expression like this. So what I want to do here in the first line is that I want to add 2 to the original value of I, and then I want to store this new value back to I, so that the value we store inside I will be incremented by 2. So this is what I do. And if I want to do this, C also provides another way to help us to finish this expression that is here. So here we use a compound assignment here. So the value that we have inside I will be the same with this one. So this line actually does the same thing with the first line here. So if you saw the expression like this, you need to know that in this expression, what this compound assignment do is that it will add I by 2, we put it here, and then assign the update value back to the left operand, that is I. So instead of writing this long expression, relatively long, we can just directly write down the expression like this. So this is the usage of compound assignment. And actually we have other compound assignment operators. We can combine the addition, subtraction, multiplication, division, remainder with assignments and make the compound assignment. So this compound assignment is the same as the following expression here. However, maybe some of you already noticed that here I say the same as, but I never said that this expression of compound assignment is equivalent to, right? Because the truth is that these two assignment is not equivalent. This V multiplied, this V compound assignment E is not directly equal to the expression here. Why? So let's check out the following example to understand why they are not equivalent. For example, this compound assignment here, I multiply compound assignments J plus K is not actually the same as this one, right? So if you write down these two lines in your code and if you print out the value stored inside I, then you can see the value stored inside I is not the same for these two lines. So the reason is that for this expression, I multiply compound assignment J plus K. This is actually look like this instead of this. So J multiply K will be calculated first, and then the return value of this part will multiply with I and then store into I. However, this line, for this expression, we will calculate I multiply J first, and then we add K to the return value of this expression. So that is why the results of these two expressions are not the same. So please be careful about this situation when you use compound assignment. And the other thing is that when we use compound assignment, we need to be careful not to switch the two characters that make up the compound assignment operator. So the correct way to write down the compound assignment is we need to put down the multiplications operator first, the the plus sign first and then the equal sign. So please don't write something like this, because this is not the compound assignment. What this expression want to do is actually this. The C will interpret that this plus symbol is a unary plus, and then you will apply it to J instead of start the compound assignment operator. So the next operator, the final operator I want to introduce is increment and decrement operator. So most common operator, so one of the most operator we want to do to the variable is incrementing and decrementing. So incrementing means that I just add 1 to the variable. Decrement means that I just subtract 1 from the variable. So that is the meaning of increment and decrement. And we actually do this operator a lot. And you will learn that when we teach you about how to use a for loop. So now you just need to remember how to use these two operators and what is the two operators look like. So increments and decrements, these two operations can actually be done using the compound assignment operator, right? We can use these two compound assignment to increment I. We can use this compound assignment operator to decrement J. However, C provides another set of operator to help us to do increment and decrement. That is 2 plus and 2 minus sign. So the 2 plus sign is an increment operator, 2 minus sign is a decrement operator. So when we apply increment operator to a variable, what will happen is that you will add 1 to its operand. And similarly, the decrement operator will subtract 1 from its operand. And these two operators are unary operator because they can only have 1 operand. And these two operators have two types. Like you can see here, we can add the increment operator in front of I. We can also add the increment operator after I. So if we add the increment operator in front of I, we will call them prefix operator, or we will call it prefix increment. And if we add this operator after I, we will call them postfix increment. So just like the first two example with variable I, we use the decrement operator with variable J, and you can see we have the prefix decrement and postfix decrement. So why we need to have two kinds of decrement and increment operator? So actually the effect of these two operators is not the same. So I will explain that in a later slide. But before that, let's check out the side effect of this decrement and increment operator. So just like I explained here, the side effect of these two operators is that they will change the value of their operand. So for example, if we just write down I plus 1, this expression itself actually don't change the value of I unless we assign the value back to I, right? But if we just write down the expression like this, the value of I will not be changed, since the addition operator don't change the value of the operand. However, for the increment and decrement operators, the value of operand itself will be changed. So let's talk about what is the difference between prefix and postfix increment. So for the prefix increment, we can call it pre-increment. The behavior of the prefix increment look like this. So we have a variable I, and the value is 1, and we can print out the value of I using this example here. Here I add the prefix increment here. So the printed message will say that I have the value of 2, because here the value of I will be incremented by 1. And yeah, and you can see the second printf also said the same things. The value of I is 2, because this printf is the second printf after the first one, so we already add 1 to I. However, if we use the postfix increment, the printed message will not be the same, right? You can see this here. So what happened here is that if we use post increment, what it will do is that it will print out the result of I first, but it will increment I by 1 after the statements that we add, the postfix increment. So that is why in the second set of statements, we can see that we print out the value stored inside I, but here I use the postfix increment. So for the first printf, the result, the value stored inside I is still 1 that we assign here. However, after we finish this line, then the postfix increment will add 1 to I. So that is why the printed message for the second printf, in this case, the value stored inside I will be 2. So that is the difference between postfix increment and prefix increment. And the effect is the same for postfix and prefix decrement. So if we use the prefix increment, it means that it will increment I immediately. But if we use postfix increment, that means that we use the original value of I for now, but increment I later. But how much later? So actually C itself don't specify a precise time, but it will be safe that for us to assume that I will be incremented before the next statement is executed. Okay, so actually our time is up. Fine. Oh, this passed so fast. So I will finish the rest slides on this Thursday. There's not much. And this Thursday we will introduce more other things. So yeah, so that is all for today, and thank you for coming.